Hello everyone. So this is our intermediate level problem statement on data science. So in this problem statement, we are going to create a decision tree classifier to classify the given data and visualize it graphically by drawing the decision tree. So first of all, we have imported all the necessary libraries, that is NumPy, pandas, matplotlib, and so. Now importing the CSV file of the data, and here we get the first 5 rows, that is because of data.head. So this data is contains sepal length, sepal width, petal length, petal width, and species. So this data is related to properties of flower, like which species of flower has what kind of sepal length, petal length, and what showing which properties. So we are going to distinguish and predict uh, on the basis of the different values of sepal length, sepal width, petal length, and petal width, like which species does the flower belong. So data.head, first 5 rows it gives, and data.tel it gives last 5 rows. Data.info it gives information about the data, that it contain ID, sepal length, sepal width, petal length, petal width. Data.column, that is the name of the column, ID, sepal length, sepal width, petal length, petal width, species. Data.species.unique, that is how many unique species are there. So there are basically 3 unique species: Iris setosa, Iris versicolor, and Iris virginica. Data.isNull.sum gives the total number of none value for each column, that is 0 in this case for every column. Data.describes gives different mathematical parameters, that is mean, standard deviation, round, etc. Data.correlation gives the correlation matrices of one column with other. But here it gives error, so I use ChatGPT to get the modified code, and here I got it this. So this is the correlation which we get, that is the relation of one column with other columns, sepal length with ID, sepal length, sepal width, petal length, and petal width. So the relation of sepal length with its own is 1, value is 1, because both are same thing. Positive value is indicating if this increases, then this increases also. Negative value indicates if this increases, then this decreases. Now showing this on C1 plot, that is SNS.heatmap plot. Better than this plot is much more better, because it is here anode is true, so we are able to see the numbers and compare it very smartly or very easily. Now drawing the cat plot, that is category plot, SNS.cat plot between species and one property, that is petal length. Let's see how much similarity two species has for this petal length property. So on plotting the graph, we can easily figure out that for some value of petal length, these two species are showing similar in nature. Like both the species has this in this range of petal length, both the species lies. So similar kind of arrangements can be found with for other properties as well. That's why it's and here, since the different properties are there and some sort of similarities are also found, that's why we are using Decision-Tree-Classifier here instead of any regression model. Now we are defining x and y variable. X contains for all rows first 4 columns, y for all rows last column. Now since the species, there are 3 unique species, we are converting that into a numeric value, that is binary digit, either 0 or 1. So we are using one hot encoder. We are defining new variable y new and transforming the species into binary digit. So this is the new y new variable, and this is our new matrix, that is for setosa. If it is setosa, then the first column will be 1 1 1 and 1. If it is versicolor, second column will be 1 1 1 1 1 here. If it is virginica, then third column will be 1 1 1, while remaining will be 0. Now converting this matrix into a data frame and assigning first column, second column, third column as iris setosa, iris versicolor, and iris virginica. This is the data frame which we get. Now concatenating this binary values data frame with the original data set, and we get the new data set. This is our new data set. Now using test train split method, we are going to train the model now. And also we have imported Decision-Tree-Classifier. Now we have defined new x, new y as 2 variables for first, second, third, fourth column for all rows, and for 5, 6, 7 column for all rows. Now test and train split method applied with taking test size as 30%. That means training 70% of data are used to train. So we are printing all the shapes of train X, train Y, test X, test Y. This we got. Similarly, we are now doing it for 80% of training data, that is 20% of testing data. So similar thing is there. And here we get different shapes for train and test. Now importing a decision-tree classifier and other related parameters to make the decision tree and calculate different values or scores. So we are importing from scikit-learn.tree, Decision-Tree-Classifier-Plot-Tree, then accuracy score, classification report, confusion matrix, R2 score, mean absolute error. Now defining CLF as decision-tree classifier and fitting the X and Y train data, and then making one new variable, that is Y predicted equals to CLF.predict X test. Now printing the classification report of Y test and Y predicted, that is how much similarity and differences then in between Y test and Y predicted. So precision is this, recall, F1 score, and support. All the scores are printed for all the three species. Training score is 1. Confusion matrix, that is matrix between Y test and that is basically it's matrix between actual and predicted value. So this is the confusion matrix we got. Accuracy score is 0.9. And now changing that binary format into species again, and check how much Y actual and Y predicted are similar. So for the first 5 rows, they are equal. That is, our predicted value is same as that of actual value that we set earlier. Now printing the predicted value, that is predicted equals to classifier.predict X test, the classifier that we defined earlier. That is the decision-tree classifier. So this is the predicted value. Now making the decision tree. So from scikit-learn we are importing tree, defining the feature names and class name. Feature names sepal length, sepal width, petal and petal width. Class names are iris setosa, iris versicolor, and iris virginica. And then writing the codes to draw the subplots for the decision tree. And then finally writing the code to draw the tree, tree.plot tree. CLF classifier, that is decision tree classifier, where all the data are input with training and testing test sets. Feature names are in, we need to write, class names we need to write, and field equals to true. And also figure.save figure in the form of by the name of iris tree classifier.png. After the tree is drawn by this code, we also want to save this figure. So we are writing this code. And on running this code, we get this decision tree. That is on the basis of petal length, centimeter. It is divided into for the 2 types. So on considering different parameters, the tree is classified at each level. So this is how the decision tree algorithm works. This tree is basically drawn using decision tree algorithm of machine learning to classify the species. Thank you so much.